we're going to start, and what I want you to do is feel free to stop me at any time because the chemical basis of life means you have to understand a little bit about chemistry. Given that it has been some time since several of you have taken chemistry, this might be a little bit frightening to you. If it is, that's okay, because I'm going to help you learn it, okay? So, the basic unit of life, what is it? The simplest unit of life is whole. A cell. Good job. We call this cell theory, and it basically says two things. Yes, ma'am.
I'm sorry, did you say we're starting on chapter 2?
I'm bouncing between them.
Okay.
Let's put chapter 1 and 2. Chapter 1 is more of an introduction to just kind of let you know this is what anatomy and physiology is about. It brings up some things like the chemistry. I found that people tend to kind of freak out a little bit with COVID. A lot of people were in high school going through chemistry being taught remotely. I actually taught chemistry to a group of students remotely during the COVID year. It was a rough road to hoe for all of us. So I try to make sure I give you guys a little bit of extra time and background. Is that okay with everyone? So back to cell theory. Two principles of cell theory. Number one, the cell is the basic unit of life. And number two, all living things are made up of cells. Your body is an amazing thing. When you stop to think about it, if you ever have, you may remember that you started your existence as a single cell. You spent about 30 minutes of your life on this earth effectively as no more complicated than an amoeba. Kind of puts it in perspective for you, doesn't it? Is there anybody who's not signed the attendance sheet?
I have.
Okay, thank you. And now, your body has on the order of something like 50 trillion cells. Now, you don't have to know that number. I'm just throwing it out there just to make you realize we start simple, but we become complicated, don't we? It's like life. It starts simple, but boy, does it get messy. And most of those cells are hyper-specialized. If you look at a bone cell, which you'll see those this week or next week under the microscope, you're gonna see it looks very different than, say, a skin cell. A skin cell looks very different from a nerve cell. That specialization is the key to the cell's function. Most of those cells cannot survive on their own. Some of them can, believe it or not. You can actually scrape the inside of your mouth, get a few of those cheek cells, put them onto a microscope slide, and look at it. We'll try to do that next week. Does that sound good to everyone? Just like to see your own cells? They're actually still alive when you put them on there. Believe it or not, when a person dies, they don't die all at once. Did you realize that? Some of the cells die quickly, within minutes. Others take a day or two to die. You can actually take cells out of the body, and if you put them into a vial or flask with the appropriate nutrients, you can grow them in the lab. Anybody here ever heard of HeLa cells? Hela, H-E-L-A, comes from the name Henrietta Lacks. Ms. Lacks was a young mother in the mid-50s from the Baltimore, Washington, D.C. area who went to a doctor and got diagnosed with cervical cancer. That's a pretty rough disease to deal with. As you can imagine, in the 50s, they didn't have nowhere near the options they have today, right? Unfortunately for her, it was terminal. And the cells that were taken in the biopsy were grown in a lab. Turned out they divide and reproduce and grow like crazy. Well, the researcher kept the cells without notifying either Ms. Lacks or her family. See where this is going to be a problem, don't you? Lydia, you're a cell researcher, I'm a cell researcher. I've got this line of cancer cells. Would you like to have some for your lab? So I give them to Lydia. Now 2 labs have them, don't you? Emily asked Lydia, oh, let's ask Lydia. Lydia, are you gonna give them the cells? Yeah, why not? Doesn't cost you anything. Helps us all, doesn't it? These cells have proliferated around the world. And even though Ms. Lacks died in the 50s, her cells still live on in countless labs today. The knowledge of this didn't come out until the late 80s, early 90s, and her family was pretty upset when they found out about it, as you might imagine. They have allowed researchers to continue to use these cells, but they always ask that it's with the acknowledgement of where they come from. And unfortunately, there was probably some racial issues involved in this. Ms. Lacks was African American. Hopefully we've come a bit further than that. But you see what I mean when I say that the cells basically give life, right? Even cancer cells, they are still living things. So the human body's made up of lots and lots of cells. We consider that level 1, basic level. Above that, those cells are grouped into tissues. Now tissues are just groups of cells with a similar function. Dermal tissue forms the skin, forms the lining of the gut, forms the lining of the abdominal cavity. You see where I'm going with this. Muscle tissue. The heart is the muscle, isn't it? You've got muscles that surround the intestines and help move the food through. You've got your skeletal muscles that help you move things. Those are examples of tissues. The tissues are then organized into organs. An organ is a specialized structure with a specific function. The stomach initiates the digestive process. That's an organ. The eye is a sensory organ, isn't it? See where I'm going with this? The heart, it's a pump. You put organs together to create a system. We might call it an organ system. The digestive system. You have the teeth, the mouth, the tongue, the esophagus, the stomach, the small intestine, the large intestine. All of those are separate organs, right? All of them have different specific functions. The teeth tear and grind. The tongue swallows. The esophagus is a transport system. The stomach begins the chemical breakdown. The small intestine is for absorption. see how the specific functions of each organ differ? But the whole system is designed for the input of food, processing of food, the breakdown of food, the absorption of energy, and the elimination of waste. Everybody cool with that? What happens when you put all the systems together? You get the complete organism. So, cell, tissue, organ, system, person. You can go higher than that. We're not going to. You don't have to know this. If you start looking at the population, we have different interactions with each other, don't we? Competition, mating, cooperation. Populations interact with each other, don't they? We like to draw that artificial line between Tennessee and Kentucky, but I can assure you there are a few differences between the populations. Down there, it's acceptable to wear orange. Up here, that might get me shot. Down there, they like football. Up here, we like basketball. Those, in turn, can interact with other species, can't they? Form an ecosystem. You see where I'm going with this? We're just going to be concerned with the 5 levels that I gave you. Cell, tissue, organ, system, body. That'd be a good test question, wouldn't it? List and describe the 5 levels of biological organization.
What were the 5 levels again?
They were cell, tissue, organ system, and then body or individual or person or whatever you want to call it, is to say the whole organism. When you answer those on the test, if I give you that question, you can put it in your own terms. If you put body and then she puts organism, you're both getting credit. Does that sound good?
Okay.
Now, you can also go below that, and a lot of people don't think of this, they're not comfortable thinking of this. This is where the chemistry comes in. Molecules are not living. They are smaller than cells. Atoms are not living, they are smaller than cells. But you've got to know how they interact. So let's go down from the cell and start looking at smaller units. Below the cell, you've got organelles. An organelle is a specialized structure within a cell that has a specific function. When we go into lab today, I'm going to get the cell model out, and I'm going to show you some organelles and how they are found in the cell. Examples would be like the nucleus, the mitochondria, can those structures live freely on their own outside the cell? No. That's why we don't consider them separate living organisms. Is everybody clear on that? Okay, below the level of organelles, you've got macromolecules. Macro means big. Now you might be asking, what on earth is a big molecule? Because molecules are small, aren't they? They're about as small as you can get and still be called whatever that substance is. A macromolecule is one that is made up of millions of atoms, thousands of atoms. An example would be DNA. Want a fact that'll blow your mind? If you took all of the DNA in a single human cell, now this is just one copy, and you connected it all end to end and you stretched it out as a single strand, it would be 6 feet in length. For scale, I'm 6'1", and that's in every single one of the 50 trillion cells in your body. It's mind-blowing, isn't it? But it also shows you how big molecules can get, but also how small a molecule is. So is everybody cool with that? So our definition of a molecule, the smallest unit of a chemical substance, the smallest unit of a chemical substance. A molecule of water is water. You cannot break it down any more than that and still be water, can you? Below that, we've got atoms, A-T-O-M-S. Atoms are the smallest chemical unit, period. You cannot break it down any further. That molecule of water, the chemical formula is H2O. That means we have 2 atoms of hydrogen mixed with 1 atom of oxygen. Together, you've got 1 molecule of water. Question? Wait a minute.
No, it's kind of just.
I told you guys, I get so desperate for interaction. You reach up, scratch your ear, I'll be calling it. Everybody feel comfortable with this?
So,
Now-
I have a question.
Sure.
So the molecule, you said is the smallest unit of a chemical substance.
Right.
And then the atoms is just the smallest unit, period? That's how you want us to, okay.
A molecule is an example of something we call a compound. A compound. Which means a combination of elements. A combination of elements. Think of water. Water is pretty unique, isn't it? It's a liquid at room temperature, but you can freeze it. Take a cup of any water outside, leave it out there for a few days, at this temperature, it's going to turn into a solid, isn't it? Yes, ma'am.
He said the molecule is a compound of what?
A compound, just a combination of elements. Make sure you get that term, elements. That'll be our next definition. Would you agree that water generally, from our understanding, is a liquid? Chemical formula of water, we said. You're saying, no, it's a solid out there because I slid on it coming in this morning. Yeah, at this temperature. But think of the warm halcyon days of summer when we get out on the lake coming up and our water skis and our boats and we're doing. You're saying, maybe you do. I have never been on a pair of skis in my life. I don't understand the concept of why anybody would willingly strap on 2 planks to their feet and go hurtling down a snow-covered hillside at a speed of 70 miles an hour, wearing nothing but a coat,
It's a lot of
controlling
padding.
yourself with a pole. Huh?
It's a lot of padding.
A lot of
So I think
padding.
it-
Different strokes for different folks. I
Trust-
have trouble walking. I honestly thought about using my cane today. I'm hurt a little.
Trust skiing on water, that is not easy. It's not easy.
I tell people.
I tried it, but I failed miserably.
Well, I'm not laughing at you, I'm laughing in sympathy because you should see me the first time I tried roller skates. You think skiing's bad, ice skating's worse. Skiing, at least you're strapped planks on your feet, right? Ice skating, no, I'm gonna strap a knife to my foot and I'm gonna walk on the ice on edge. Then I'm gonna spinning circles. Nope. Anyway, back to water's wet, it's a liquid. When you think of hydrogen, you realize it's a gas, right? It is very reactive, it is explosive. If you don't believe me, Google the word Hindenburg and take a look at the first picture. You're gonna see a burning airship coming down because it caught fire. Oxygen is so reactive and so common in the atmosphere that we have a specific term for the reaction. It's called oxidation. If I set a lump of iron out here on the wall out in the parking lot and I just leave it there and I come back in a week, it's gonna have rust on it. Because it spontaneously oxidizes. Those two are very different than water, aren't they? See where I'm going with this? But when you combine them in that 2-to-1 ratio, you get a different substance called a compound, and that compound is water. Does that clarify it enough for everyone? Is there anyone who does not understand? Okay. So elements. Elements are the simplest chemical units. You cannot break them down any further. You cannot make it any smaller. Hydrogen's an element. It's the simplest one.
You said the elements are the simplest one?
Yeah. They're the simplest chemical, period. You can combine elements in a lot of different ways. You can combine a lot of different units of elements. There's a whole field on the chemistry of carbon, for example. It's called organic chemistry. You combine carbon and hydrogen in so many different ways, it's amazing what you can get. Y'all ever heard of hydrocarbons? You ever get stuck behind one of these old trucks and it's moving off in the red light and it releases that big cloud of gas? That smell you got, that's hydrocarbons. Is everybody comfortable with all these? Now below that, we have subatomic particles. Protons, electrons, and neutrons. The number of these particles determines what type of element it is. The number of these particles determines what type of element it is. To understand this, you look at a periodic table. On the top, you're going to see a row with 2 elements in it, one on the left and one on the right. Below that, you're going to have a row with 8 elements in it. Below that, another row with 8 elements. You get an idea. If you know what those locations and numbers mean, you can figure out how any 2 chemicals will combine to make a compound. It's like reading a map. How many of you know how to read the periodic table?
I have an idea, we learned a little bit.
It's okay if you don't. I was afraid people would say this, but this is why I say honesty. Never apologize for not knowing something. Sin is never in not knowing, it's in not learning how to when you have a chance. Would y'all like to learn how to read the periodic table? Okay. Call up on your favorite internet connected device a periodic table. If we cover any of this on the exam, I will let you use a copy of the periodic table. You will be allowed to bring a copy with you to the exam. Does that sound fair to everyone? Maybe even a little generous on my part. Joking aside, it's just a tool like anything else. If you know how to use it, it can be very helpful. So if you take a look, you'll see that it's divided into rows and columns. The locations of those rows and columns tell you everything you need to know. Let's take a look in the upper left-hand corner, and you should see an H. Does everyone see that? That is the chemical symbol, the chemical symbol. I am not going to ask you to memorize every chemical symbol on the periodic table. If you look at it and use it often enough, you probably will learn. If I'm telling you what it looks like off the top of my head, that ought to tell you how many times I've looked at this thing. H is hydrogen. If you look over to the right, you see He for helium. Below hydrogen, you see Li, which is lithium. Is that correct? Is the next one Be, beryllium? Oh, I'm good. No, like I said, I've just looked at it a little too much. Most of these are simply the first letter or two of the name of the element in question. A few of them go by the old Latin names. So if you look down near the middle and you see Fe, that comes from the Latin ferrum, which means iron. Au, does everyone see that? Comes from the Latin aurum, gold. Getting an idea here, I think. Pb comes from the Latin plumbum. You ever heard of a plumber? Plumbers work on pipes, don't they? Pipes for centuries were made of lead. Just a little bit of trivia. If you don't know what it is, that's okay. Stick that into Google and say chemical symbol Pb, and it'll come up with the term lead. You've got access to the greatest reference humanity has ever devised. Thank you, sir. Okay, above that, you should see a number. We go back to hydrogen, the number is 1. That's called the atomic number, the atomic number. And yes, you do need to know that term. It's the number of protons. So how many protons does hydrogen have? 1. Generally, the number of electrons equals the number of protons. Generally, the number of electrons equals the number of protons. Now, below that, you will see another number that is a decimal. Am I right? It goes out to like 4 decimal places. Okay, that number is called the atomic mass. The atomic mass. It is the number of protons plus the number of neutrons. Now, the atomic mass of hydrogen should be about 1. Am I correct on that? Yes? No?
So,
Yeah.
okay, just want to make sure.
That one that goes out to like 5 to 10 decimal places, that's the atomic mass.
Can you give the definition of that again?
It is the number of protons plus the number of neutrons. The number of protons plus the number of neutrons. So if you want to figure out how many neutrons an atom has, you subtract the atomic number from the atomic mass. Now, since this is not a chemistry course, we are always going to round the atomic mass to the nearest number. So we are going to say that hydrogen has an atomic mass of 1. We're going to ignore the decimals. Is everybody okay with that? So if the atomic mass is 1, the atomic number is 1, how many neutrons does hydrogen have? 1 minus 1 is 0. It does not have neutrons. Flip over there to helium. Helium has an atomic mass of 4, am I right?
Yes.
You know you're a nerd when you've memorized the periodic table. It has an atomic number of 2. So how many protons does helium have? 2. Does everyone agree? Because that's what the atomic number tells us. How many electrons does it have? Because those are always equal, right? Everyone agree? If you don't understand, you better tell me now, because if you're lost here, you're going to be really lost in a minute. Are you with me? How many neutrons does it have? Kira? 2. Good job. Everybody see that? 4 minus 2 is 2. Go below that to F, fluorine. Let's see. The lady here whose name I don't remember.
Micaiah?
Huh?
Micaiah?
Micaiah, thank you. How many protons does fluorine have, Micaiah?
9?
9. Everybody agree? Emily, what's the atomic mass of fluorine?
18?
19. Does everyone agree? So, Alyssa, how many neutrons does it have? 10. Did everyone get that? Good job.
Okay, so you said neutrons equals,
Mass minus number.
mass times number, okay.
So 19 minus 9 for this example. That help?
Yes, just wanna make sure.
Sure. You never go wrong asking questions. Everybody comfortable with that? Okay. The way this fits together, this might work better as a table. Y'all like tables? So let's make a table in your notes. It's going to have 4 rows and 3 columns. 4 rows and 3 columns. Column 1 is going to be particle. Column 2 is going to be charge. Column 3 will be mass.
What was the first column again?
Particle.
Okay.
And our 3 particles are going to be proton, electron, neutron. Proton, electron, neutron. It doesn't matter what order you put them in. Proton, neutron, electron. For the proton, under charge, you're going to put a plus sign because it has a positive charge. Under mass, you're going to write the number 1. It has a mass of 1 unit. We're not going to worry about what the units mean. This isn't chemistry class. Is that okay with everyone? Under electron, put a minus sign for charge because it has a negative charge. Under mass, put a 0. Now, I'm not saying electrons are massless, okay? I just want you to understand they are so light compared to a proton that if you put them on a scale, you wouldn't be able to get a weighting. It would be like putting an elephant on this side of the balance and a housefly on this side of the balance. Do you think the scales are going to tip? It's all going to the elephant, isn't it? Is that okay with everyone? Makes it simple. Under neutron, under charge, put a 0 because it has no charge. Under mass, put a 1. Does that help you understand it? Okay. Every atom has a nucleus. And the nucleus is going to be all of the protons and neutrons put together. So if we're drawing helium, there's 2 neutrons. Everybody see that? And there are 2 pluses for the protons. That's the nucleus of helium. Everybody cool with that? Yes or no? Marley's looking at me with a frown. You okay with me? Okay. The electrons orbit around the nucleus. And there are 2 of them, the little E- electrons. Not too bad, is it? Everybody understand this so far? Now, electrons are what determine reactivity. They determine reactivity. Reactivity is simply how likely are things going to be to combine? How likely are things going to be to combine? Yes, Kara?
What did you say determines reactivity?
Reactivity.
Reactivity.
Yeah, the electrons determine reactivity. Now I'm going to teach you the shortcut that for whatever reason, none of my professors ever taught me, and I didn't even figure out until I already had my PhD and been teaching for years and years. Because one other professor came in and sat in on one of my lectures and said, "Why are you teaching them the hard way?" I looked at her and said, "The hard way?" She said, "You don't realize there's a different way to teach this?" I said, "No, this is how I learned it." And she showed me something, and I swear I was a converted. Say there's nothing like a fanatic, like a new convert. That was the truth. So electrons always have specific orbits. It's like a racetrack. We may call those an orbit or a shell. And each orbit can only hold a set number of electrons. The orbit closest to the nucleus can hold this many electrons. 2. And only 2. It can never, ever have more than 2 electrons. Is everyone clear on that? Take a look at the very first row of the periodic table.
How many elements are in that row? You mean that corresponds to the number of electrons in the orbit? Uh-huh. And nobody ever told me that. That makes it easy, doesn't it? Would anybody like to take a guess how many electrons orbit number 2 can hold at max?
Is it 8?
You got it. Everybody see that? How many elements are in row 2? 8. Oh my gosh. Could this be any easier? Now, why on earth do people not get taught this? It's like reading a map, isn't it? Now, remember though, once you fill orbit number 1, you already have 2 electrons in the inner orbit, don't you? Then you start filling the second orbit. So if you look at lithium, that's element number 3, it's all the way on the left side on row number 2. It has how many electrons? 3. Does everyone see that? It has how many in orbit number 2? 1. Because you have to fill orbit number 1 first. Does everyone see that? So even though row 2 has a maximum of 8, if you go all the way over, I believe, is that neon? Ne? It should have an atomic number of 10. So it has 2 electrons in orbit number 1 and 8 electrons in orbit number 2. Does everyone see and agree? We're only going to worry about the first 3 rows. This is biology, not chemistry. Let's not get down into that big mess in the middle. Is everyone okay with that? You're saying no? I'll let you prepare a lecture and teach it on the big mess in the middle. I'm just teasing. Everybody okay with that? Okay.
Can you repeat how you said each row shows the,
Maximum number of electrons in that orbit. Row 1 has a maximum of 2. Row 2 has a maximum of 8. Row 3 has a maximum of 8. So right below neon, do we have xenon? Is that what's below it? What's number? Huh?
This is argon.
Argon, sorry. I missed one. Everybody see that? It has a total of 18 electrons, doesn't it? 2 in orbit 1, 8 in orbit 2, 8 in orbit 3. Okay, I want you to write down the rule that I'm going to tell you next. Every atom wants a full outer orbit. It wants a full outer orbit. Everybody clear on that? If you take a look at lithium, how many electrons does it have in its outer orbit? 1. 3 minus 2 that are in the inner orbit, it only has 1, right? Now it has 8 slots. So to fill that outer orbit, it would have to go out and find 7 more electrons, wouldn't it? Don't write this down. Is that very efficient? If I opened that door and started bringing people in here, how long would it take me to find 7 additional people to sit in here? Since it's class time and there's not a lot of people or traffic in the halls, it might take 30 minutes, right? It's not a very efficient process. So what lithium is going to do is a trick. It's going to kick that single electron out of its orbit. How many electrons does it have now? Does everyone agree? How many electrons does it have in orbit number 1? 2. Is orbit number 1 full?
Yes.
Orbit number 1 is now the outermost orbit, isn't it? That's a good trick, isn't it? Everything in that first column has only 1 electron in its outer orbit. They're going to kick that electron out. How likely are they to do it? They are so reactive. In other words, they are so willing to kick out that electron that you cannot leave some of these metals out in air. Everybody see sodium Na? If you have pure sodium in a jar and you want to put it in your storeroom, you have to fill that jar with oil. Otherwise, the sodium will react with the oxygen in the air. It's so reactive that if you took a chunk of sodium about the size of, say, one dice, paradise, and you threw it in a toilet, it would react with enough explosive force, it would crack the toilet bowl. Don't ask me how I know that. I think the statute of limitations has run out. Does everybody see what I mean by reactivity? Now let's move to row number 2. Is that beryllium, Be? How many electrons does it have in its outer orbit? 2. Does everyone agree? It has a total of 4, but it's got 2 in the outer orbit, 2 in the inner orbit, right? It has how many slots?
6, 8.
Total of 8, but 2 of them are filled, so it has 6 empty slots. Does everybody agree? Is it going to be easier to grab 6 or kick out 2? Kick out 2. You mean there's a pattern here? Oh my gosh. What's the next one over the gap? Is that the big N? Nitrogen? What is it? Boron, the B. It has a total of 5 electrons. 3 in the outer orbit, 5 empty slots. Kick out 3 or grab 5. What are you going to do? Boom. Everybody see how this is going? Okay. We are forming what we call ions. Ions. I-O-N-S. An ion is a charged atom. How many protons does lithium have?
3.
Everybody agree? How many electrons normally?
3.
So a +3 and a -3 give us 0. Does everyone agree? Lithium by itself has no charge. However, we're going to kick one of those electrons out because we want a full outer orbit. Everyone agree? So we've got 3 protons and 2 electrons, yes? +3 -2 leaves us with a charge of +1. Is there anybody who does not understand how I got that number?
You're saying that lithium has the charge of 1?
When it forms an ion, it has a charge of +1. Question, Marley? Question?
No, it wasn't a question. I just don't get it.
Okay. Protons have a positive charge. Do you agree? +3. We know that because the atomic number is 3, right? How many electrons does lithium have?
6?
3.
It says 6.
No, that's the atomic mass.
Oh, okay, that's probably where I went wrong.
That's okay. This is a chance to make mistakes. Does it cost you points now? It's free of charge, isn't it? If you make a mistake now, are you going to make that same mistake in the exam? That's why we're learning. Does that help you? So we have +3 and -3. We kick one of these minuses out, right? Everybody agree with me? Are you with me, Marley? 3 minus 2 leaves us +1. Does that help? Okay. Good job. Any questions? All right. Let's look all the way over at fluorine again. Has 9 total electrons, doesn't it? Does everybody agree? So out of our 9, 2 of those are in the inner orbit. So how many electrons does it have in the outer orbit? 7. Everybody agree? So it's only got 1 empty slot, isn't it? Is it going to be easier for it to grab 1 or kick out 7? Grab 1. So it's going to grab that electron, and it's now going to have 8 electrons in the outer orbit. It has a charge of -1. Does everyone see that? Because if you got,
Run that one more time, please.
how many electrons does it have total? Normally?
9.
9. We agree that it's going to grab 1 to have 10. Does everyone agree? 10 negatives. Everybody with me? How many protons does it have?
That's 9.
9. Plus 9 and minus 10 comes out to -1. Everyone agree? See how this works? Column 1 is a +1. Column 2 is a +2. Column 3 is a +3. The 4th column is going to be a 4. That's the big C, isn't it? Carbon. Is carbon going to want to grab 4 or kick out 4? And yes, this is a trick question. It's not going to do either one. Now we know in the American political system, citizenship doesn't matter. Only your party, loyalty to the party. That's why we have to be a Democrat or we have to be a Republican. You cannot be in the middle, right? Well, carbon's in the middle. Carbon is going to share. Carbon is going to share. That means it can either be a +4 or a -4. It goes either way. It's the swing voter. It's like, I don't like that carbon. I don't either. Organic chemistry was brutal. And I'm not joking when I say that. The fact that carbon does this makes it almost unique among the elements, and that's why we say that life is carbon-based. So, Kira?
So, after since that 4th column is both of them, would the next one be -3?
You got it. Everybody see that one to the right of carbon? That is column 5. That's going to be a -3. Then the next one to that is going to be a -2, isn't it? Oxygen, that column is -2. Does everybody see how I'm getting these numbers? The one next to that is a -1. So we count up. +1, +2, +3. 4 is right in the middle, can be a plus or minus. We start counting new. -3, -2, -1. You have to get the charges equal when you form a compound. Write that sentence down. The charges have to be equal when you form a compound. As an example, lithium is going to form a +1 ion, isn't it? Does everyone agree? Fluorine is going to form a -1 ion, right? What's +1 and -1 when you put them together? It's a 0. So lithium fluoride is a compound with a net charge of 0. Does everybody agree? You want one that's harder? Aluminum. What is the charge on aluminum? Somebody volunteer or I will pick on you.
What was the question again?
What is the charge on an ion of aluminum? Al.
Is it 3?
+3. Everybody agree with that? We're going to combine aluminum with oxygen to form aluminum oxide. Is everyone okay with this? What is the charge on oxygen? Who is willing to volunteer? Raise a hand. If I don't get a hand, I'll pick somebody at random.
Should be -2.
-2. Does everyone see that? If you don't understand how I got that, raise your hand.
I don't understand this at all.
How about I give you some time with me one-on-one in lab? It might work out better if we just point it. Question? I told you all, you stretch, scratch, anything, I'm gonna call on you. Aluminum is a +3. Oxygen is a -2. Do those equal each other? So we need to get the charges to balance, right? So what we're gonna do is multiply them by each other. If we multiply aluminum's charge of +3 by 2, that gives us a total of +6, doesn't it? So what in essence we're doing is we're putting 2 aluminum ions side by side. Does everyone agree? See where I got that? So our total charge is +6, yes? How many oxygens do we need if oxygen has a charge of -2? 3. 3 times 2 is 6, -6. So aluminum, when combined with oxygen, you're going to have Al2O3. Everyone see that? And that, folks, is how you read a periodic table. With that bit of knowledge that I just gave you, you can combine and balance any chemical equation. Kara's shaking her head saying, why didn't they make it that easy when I learned chemistry?
I don't want you to make us do the problems with them. I hate that. I hated it.
Listen, I struggled with it so bad in high school. I'm thinking, if they would have taught it like this, I might have been okay. Granted, I would still probably confuse myself, but I would have been okay.
How many of y'all would like me to take a few minutes in lab to do a few problems on the board? Raise your hands. We'll do that. We'll do it in there because I want you all to clear your minds before we go in there, and I want to have a little bit extra time to do it. Does that sound okay to everyone? Basically, that's all the chemistry you're going to need. And as Kara will just attest to, I've given you about the first, 4 weeks, would you say, of chemistry in 40 minutes. It's a lot easier with that periodic table, isn't it? You learn to read it, you can do anything. It's like a map. And hey, the way our society is connected, You can be on top of Mount Everest. If you climb Mount Everest and you need to climb in a periodic table for whatever reason, you pull out your satellite phone and hit Google, can't you? But if you don't know how to read it, you don't know what the numbers mean. It's a useless tool. Everybody okay? Y'all want another joke? Something to lighten the mood. Y'all are looking very grim. What's the best thing to come out of the state of Tennessee?
Not their football team.
Highway 27. Y'all got it. Okay. Everybody okay now? Would you like a sample quiz?
Does that mean? questions
It
that
means
common
it's
sense?
not going to count, but it would give you an idea of what a quiz would look like.
Yes,
Yes.
Okay. You don't have to write these down, but typically, since these are 10-point assignments, I try to give you either 3 questions or 5 questions. Okay? So a good quiz would be, which is the smallest unit of chemistry? And what would the answer be? Who can tell me?
Adam?
An atom. What is the smallest unit of a compound? And the answer would be molecule. What are the 3 subatomic particles? Their charges and their mass. And you could draw that table, couldn't you? Proton, neutron, electron. Proton has a mass of 1 plus charge. Neutron has 0 charge, mass of 1. Electron has a mass of 0 and a negative charge. You know how, like I said, you don't have to write this down. I'm just trying to give you an idea of what it would look like. Everybody cool with that?
Question, would you count spelling against us? Sometimes I can't spell.
Spelling never counts against you as long as it is reasonably close.
Okay.
If you spell xenon, Z-E-N-O-N, instead of X-E-N-O-N, I will give you credit. If you spell xenon, A-R-G-O-N, which is actually argon, I will not give you credit.
Okay,
Is that fair?
fair enough.
Because those are 2 different things.
Yeah, makes sense.
So what about that last column? What is their charge? 0. They never form ions. They never form ions.
What doesn't form ions? What doesn't form ions?
The very last column.
You're saying that from, wait,
The very right-hand column. You all are such a good group. I like you guys. It's gonna be a good class. Y'all are actually conscious in the morning. I told y'all about that class I had where I lectured for 15 pages of notes, didn't I?
Yeah.
None of us had a good time that semester. I want you to understand something about the last column. Those elements never react, they never form compounds. They never react, they never form compounds. They can't. The last right-hand column. They're sometimes called the inert gases, I-N-E-R-T. Inert just means non-reactive. They're sometimes called the noble gases, it just means the same thing. And here is my dirty trick that I play every year, so you're guaranteed to get this right on the exam if you listen. You're guaranteed to get it wrong if you don't listen. If I ever give you a problem that has something combining with one of those, it's not going to form a compound, is it? You're going to write no reaction, or you're going to write does not happen.
I had one student write, not anything along the lines of saying that you understand that those things do not react and form a compound. Everybody fair? Is that fair? I'll let you know. And remember, you are going to be allowed to bring a periodic table with you for exam one. I do think that's fair, don't you? Yes, ma'am?
I was gonna ask, for the study guide for our final exam, or however we do it, I forgot what you said, are we gonna have like any form, are you gonna help us out with the study guide or anything, or is it all gonna be based on the notes that we take?
How many of you would like a study guide for exam one? Put it. We will dedicate, let's say, at least 15 or 20 minutes of a lecture period or a lab session if you're willing to hang around, maybe even 15 minutes of break. We'll have some time where I will help you guys build a study guide. And how many of you would like it if I posted a sample exam on Blackboard so that you could look and see? Remind me to do that. My brain, it's like I said, it leaks. It's old. They'll have to. Or was that, I heard somebody, you had a question, Karen?
Yeah, I think it was last August, you, not 2024, but 2023, you had someone who wrote down a series of questions that would be a study guide, and they sent it to you.
We'll do something like that.
Okay.
I'm an old dog, I can't change my tricks at this point. It seems to work. Some of y'all are looking at me with daggers in your eyes. If you want me to give you the hard test, do it the hard way, I can. I much prefer these, but I mean,
Let's do these.
basically what I do, what Kira's asking. She had me before, so if you really want to know anything about me, she can give you straight up. I think we got along well, didn't we? I didn't beat you too much, did I? What I do is when I'm giving you the study guide, if I have one of you all willing to more or less be the secretary and write down what I'm doing with the guide, and you email me that, I'll actually make the test from that. That way everybody has the same study guide and questions. I am making it from the actual study guide you're using. But you'll have to be willing to type it up and email it to me. I'm not going to do it. That's okay. That help you? I'll do anything that will help you learn. I won't bend over backwards because my body just doesn't do it. It'll help, I'll try. I have to call an ambulance and lift me up off the floor, but I'll try. I want you to be successful, that's my own goal. That okay with you? Now, technically, class doesn't end for another 5 minutes, but what I suggest is we stop the lecture here. We'll take our 15-minute break. Instead of starting at 11, we'll start at 5 till 11, and I'll use that extra time to work a few problems. Does that sound okay? Okay, so take your 15, I'll see you in the lab. Remember, it's gonna be 5 till. You still get the same amount of instructional time, you still get the same amount of break. And thank you for the compliment, Alyssa. I know you weren't intending to give me one, but what you said about if somebody had taught you this way in high school. Bottom line, I tell people, work smart, not hard.
Yeah, I understand that completely. I learned the different things at Lindsay, there were different ways they tried to make it easier instead of more difficult. And at my high school, because I went to Casey County, so I don't know if you know where Casey County
Well,
is.
people say age is just a number, and there's generations and this and that, but the truth of the matter, and it is true, you and I have different outlooks on the world because of different experiences. It's not that mine's better, it's not that mine's worse, it's just different.
Yeah.
I have a devil of a time trying to teach an online class because it goes against every bit of experience and training I've had.
Yeah.
But what I try to do, I've tried my best to reach you guys where you live,
Yeah.
to use the technology to make things easier. I've got a friend who was doing the whole Gen X versus Gen Z thing. He said, yeah, they don't even know how to drive a manual transmission. So I looked at him and I said, honestly, why would they need to?
Yeah.
And he said, what do you mean? I said, dude, when's the last time you bought a new car that had a manual transmission? Well, it's been about 20 years. I said, exactly.
But see, yeah, when you look at it, it's not often that you find one that is a stick.
Bingo. You might, but it's generally going to be used. And as I told him, I said, this generation growing up doesn't have the options we
Yeah.
had. They don't need to know because they're not available. It's not a skill that's useful anymore.
Yeah. Because the only reason I learned how to was my mom was like, okay, you need to know at least how to in case your friends say they have an older truck, something, and they need
Bingo.
help drive.
But that's what it really hacks me off when I hear people throwing off on this generation or that generation.
Yeah.
People talk about my generation. Well, you don't know how to do this online. You don't know how to do that online. Well, why would I?
Yeah.
That's why I asked you to help Raven, and I really appreciate both of you working together.
Yeah.
Because if I tried to help her, I'd have messed it up.
I understand completely.
Well, thank you. I appreciate that. Are y'all just hanging out, or are y'all waiting on me?
I'm just hanging out.
Okay, that's fine.
I do want you to know I'm lost in the sauce. I have no
I
idea
am
what's
too.
going on.
Y'all want to
I was
come up
lost
here
in
and
this
see a
one.
little one-on-one?
I'm gonna say, honestly though, when you re-explained it, I remember some of the stuff. Although I graduated from Casey County in 2020, technically I just graduated 24 from Lindsay, but then I decided I wanted to come back and do PTA here,
Good for you.
and I'm like, man, this would have made things so much simpler.
Well,
It's just,
I've been teaching quite a while.
yeah.
I've learned a few tricks in my time.
All right, we'll see you.
Okay, are you just hanging out, Haley?
Yeah.
How many of you want extra help?
Is there tutoring over there?
There should be. Mm-hmm.
Tutoring?